Welcome to the beginning of chapter 8. Today, to dive right in, we're going to start talking about inverse variation. Now, there's two types of variation we're going to cover in this chapter. One that you've already seen, and that's going to be direct variation. And then our new one, which is inverse variation. For direct variation, what we're talking about is a relationship y equals k times x. Now, k is the constant of variation, so basically it's just y equals some x being multiplied by a constant. Now, this should make you think of a line. Now, specifically a line that goes through the origin. There's going to be no y-intercept. It's not being shifted. It is literally just every x value being multiplied by that constant to give you y. Now, one of the big things when we're talking about direct and inverse variations is figuring out what that constant is. That's what this is for right here. All right, so if you notice, if I want to know what k is, if I divide both sides by x, that's how I get that second relationship down below. Now again, I want to emphasize that that second one, that is not the equation. The one highlighted in blue is the equation. The bottom one is a way for us to find k. If we suspect we have data that is direct variation, we can check. Because every y and x, when you take y divided by x, every pairing should divide to be the same value, that same constant. Now, let's turn for a second to our new one, inverse variation. So what inverse variation is now y equals k divided by x. So this is going to be a very different type of equation. We are now dividing by x. Now, again, the goal usually is to find what that k is, find that constant of variation, because once we know that, we can write the equation. Well, this time to figure out what k is, I'm going to take that equation multiplied by x, and it gives me that. So what you'll notice is for these inverse variations, it's different. That constant means every xy pair multiply to that constant instead of dividing to that constant. But again, when I'm telling you to write the equation is this that's highlighted in purple. That is the inverse equation. The bottom one is again just a tool to find your k, to find that constant to put back into the equation. So just to highlight some of those things, k is a constant ratio of x and y when we're talking about direct, and basically it's a linear equation with a y-intercept of 0. When we're talking about inverses, this time k is a constant product of x and y. And when two quantities vary inversely, as one quantity increases, the other decreases proportionately. Now what we're going to do to get some practice with this, I have two data sets here. And I'm going to use the definition of k to show why these are respectively a direct and inverse relationship. And then I'm going to write the equation of each. Now, so for this first one, we already know is direct, but let's take a look at why it's direct. So remember, for direct relationships, that constant is from y dividing by x. Whenever I take y divided by x, that should give me a constant value. So let's try it. Let's take 8 divided by 0.2. That gives me 40. 20 divided by 0.5 gives me 40. 40 divided by 1 gives me 40. 60 divided by 1.5 gives me 40. So if you notice, every one of these is the same, okay? When I took y divided by x, I was always getting the same constant. That is what tells me that this is in fact a direct variation. Again, because x divided by y, or y divided by x, was always the same value, was always that 40. So that means that is my constant for this direct variation. Now, to write the equation, because remember the more important part, once I know what k is, I need to write the equation. Well, remember, direct relationships are linear. So the equation for this particular one, because now I know k is 40, the equation is 40x. Y equals 40x. That's how I can relate x and y together. So again, you have to find k, then you have to go and use k to write the equation. All right, so this one we know is inverse. But again, let's prove why. So for inverse, we know that that constant of variation is every xy pair multiplies to be that constant. So let's check it out. 2 times 15 is 30. 4 times 7.5 is 30. 10 times 3 is 30. 15 times 2 is 30. Now, again, notice they all multiplied to be the same thing. And no, that is the definition of being inverse. So that means my k is going to be that 30, that constant that they're all multiplying to. But now, when I need to write the actual equation, remember, the actual equation is written in the form y equals k divided by x. Finding that k is not the equation. Plugging the k in is the equation. So the equation itself, to relate x and y is 30 divided by x. And that is my equation to that table. All right, so let's keep moving right along. So your math class has decided to pick up litter each week in a local park. Each week there's approximately the same amount of litter. The table shows the number of students who worked each of the first 4 weeks of the project and the time needed for the pickup. All right, now remember there's 2 ways that we need to do this, okay? There's direct or inverse. Now when you don't know, you just have to try and then see. So I'm going to check to see if it's direct first. Okay, and remember direct, if it is direct, I should be able to take every x or every y, divide it by x, and they should all be the same thing. So let's try this out. First, let's take 85 divided by 3. So 85 divided by 3 is 28.3 repeating. 51 divided by 5. Well, 51 divided by 5, that's only 10.2. So notice when I try to use that definition of k for direct, notice it's not working. I'm not getting a constant value when I take y divided by x. And I should clarify here like that. So this can't be a direct variation. Again, trying the first 2 points, it already falls apart. I got 2 different values when I took y divided by x. So that's telling me this is not direct. Well, let's see if it's inverse. Remember, for inverse, that means every x and y will multiply to that constant. So let's try it. 3 times 85 is 255. 5 times 51 is 255. 12 times 21 is 255. Or is 252. And 17 times 15 is 255. All right, so Notice all of these are coming out the same. Now, there is that one that's slightly different. Now, because we're talking about approximating models, I mean, if there's one that's a little bit off but everything else is the same, pretty good argument that this is actually an inverse relationship. And we're going to say that inverse relationship has a K of 255. All right? So all the XY pairs are multiplying to either be 255 or very close to 255. Now, what that means is my equation. Remember, the equation itself is y equals that K value over X. So when they ask for the equation, remember, finding K is not the equation. You have to take that K and plug it in. That is what gives you the equation. All right, so how many students should there be to complete the project in at most 30 minutes? All right, well, here I was using Y to represent my time. So essentially what they're doing is they're saying, hey, for 30 minutes, I want to know X. I want to know how many kids do I need to finish it in that amount of time. Well, hopefully you remember solving something like this when we were doing our trig unit. So if I have X in the denominator, well, I'm going to multiply it over. Now, I realize multiplying it over is not actually solving it, but it's getting us a step closer. At least that X is no longer in the denominator because we definitely can't do anything with it down there. Well, to figure out what that X is, I'm going to divide both sides by 30. So when I divide both sides by 30, I get 8.5. Now, we can't have 8.5 people. Okay, so I'm going to round that. So I'm going to say about 9 students. If we want to be able to finish it in a half an hour, we're going to need at least 9 kids to do that, 9 students. All right. So let's keep moving. So one of the big things is writing inverse variation equations. Now, we've already been kind of practicing this, but to keep the practice going, I've set up some step-by-steps for us. So first, you want to set up the structure of your equation. So here, we're talking about inverse. Okay, each of these is inverse. So we're going to be using y equals k divided by x. We want to plug in the given values to find k, and then plug k back in to write the true equation. So let's take a look at this first example. Suppose x and y vary inversely, and x equals 4 when y equals 12. So again, we have our basic setup. We know every inverse variation is going to follow this y equals k over x pattern. And I've been given a setup. I've been given when x is 4, y is 12. I'm going to plug those in. So I can use that to find k. So now I can multiply both sides by 4. Excuse me. And I can get that k is 48. Now, what I need you to know, though, that is not my equation. That is a stepping stone to my equation. I have to actually go and plug that back in up there. So my actual equation is when I actually put in that 48 for k, as this is the relationship between x and y. So again, always make sure you're plugging it back in. And for the second piece, I can also ask you what y is when I give you an x value. So if I give you x equals 10, You should be able to plug that in for me and tell me that y is 4.8. All right? Most of these will always have two parts. It'll want the equation, and it'll want you to determine a value when I give you an x. But the structure is always the same. Always take the same 3 steps when you're working on these types of problems. All right, suppose x and y vary inversely, and x is 2 when y is -5. What function models this inverse variation? All right, so again, I'm going to start with the basic structure of an inverse variation. And now I'm being given some information. Y is -5, and x is 2. So when I plug those in, because I know that it's inverse, it tells me that in the problem. When I plug those in, just multiply the 2 over, and I get that k is -10. So I have my constant of variation. But again, to actually solve this problem, the true equation is when you plug that k back in, and you get y equals -10 over x. That is our true equation. And I can use that equation for my second part. What is y when x is 4? Well, if I plug in 4 for x, I get that y should be -2.5. All right, let's keep it going. One more example. Suppose, again, the x and y vary inversely. This time y is -4 when x is -8. Again, we take that basic structure that we know all of these follow. So this time y is -8 and x is -4. So I want k, so I multiply that -4 over. So k is a positive 32, because -8 times -4 is a positive 32. But again, the true equation comes from when you take that, you plug it back in. So y equals 32 over x. So what is y when x is 12? Well, I plug 12 in, so 32 divided by 12. So y is 2.6 repeating, or as a fraction, that would be 8/3. All right, now, one of the big things to remember from these notes, okay, a big idea is remembering finding k is not the equation, okay? Do not stop once you find k. You have to plug k back in because this is the true equation. A true equation relates x and y to each other. So whenever it asks for the equation, you have to put it in the form y equals that number over x. You absolutely must plug it back in. So that is actually all for our notes today. So thank you for joining me. Make sure you have all of this written out so you can come back ready to do your practice work.